In this video, we are going to be dealing with some constant velocity problems. Actually, we're not going to be dealing with problems straight away. First, I'm going to teach you guys how you can resolve velocity vectors, or when you're given speed and direction, how you can use that and find out the velocity vector. Now, before we do any of that, it's important to understand what a velocity vector looks like. So I've written over here, it looks like a times I plus b times j meters per second. Now, what this basically means is, if you take an example with actual values, so let's say you have 3i plus 2j, or in fact let's say 3i plus 4j meters per second. Now let's say this is what the velocity of a certain particle is. Now it's important to understand what this basically means. Now, as we know, I is a vector in the horizontal direction and j is a vector in the vertical direction. So 3i and 4j basically means that every second this object that we have here moves 3 units right and 4 units up, which is why it's the vector of the velocity, the vector of its velocity is basically 3i plus 4j. Now if we draw it, that will be able to give us a better idea. So yeah, this is what it looks like. Okay, now if let's say you want to work out what the speed of this let me just redraw it. In fact, yeah, now let's say if you want to use this and work out what the speed of this particular particle is. So one thing that you must remember is that speed is always equal to the magnitude of the vector of the velocity. So that means speed is equals to square root of 3 squared plus 4 squared. So that means speed is equal to 3 squared is 9, 9 plus 4 is 16, so 4 squared is 16, 16 plus 9 is 25, square root of which is 5 meters per second. So that means altogether, this object basically moves 5 meters every second. Now, it's important to see what this looks like once you break it down, because if you don't understand the background of it, then you're gonna have trouble later on. So 3i plus 4j is basically its movement broken down into horizontal and vertical parts. So every second like I said, that it moves 3i, or 3 units towards the right, and 4 units upwards, which is why it's 4j. And combined, this object moves 5 meters per second in this particular direction that we see here. Okay. Now, hopefully you guys have understood this. And the reason why we've taken rightwards and upwards, I should point out, is because I and j, they're both positive. So remember, in your first quadrant, your x and y, they're both positive. In the second quadrant, x is negative and y is positive. In the third quadrant, x is negative and so is y. And in the fourth quadrant, x is positive but y is negative. Now, there are a couple of important formulas that you must remember. Now, a couple of formulas that we're still going to use. One of them is speed is equals to distance upon time. Right, we're still going to use that, but the thing is, we will not always have the speed, and we will not always have the distance. Sometimes we'll have the velocity and we'll have the displacement. So sometimes what we're going to do is we're going to replace speed with velocity, and when we do that, it's going to be a vector, and we're going to replace distance with displacement, and again we're going to be dealing with a vector here, and time remains the same. And we'll see what this looks like once we do a couple of problems. But right now, what I want to focus on is how you guys can use the given information and use that to resolve or find out the velocity vector. This basically is called resolving constant velocity. It's something that I posted on my Instagram also, and you guys asked me to make a video on it, so here I am. Anyway, so this is what it may look like. There are around 3 to 4 cases that I'm going to discuss with you guys, and pretty much everything falls inside of that. I mean, you won't find anything outside of that. Okay, so example number 1 is that you may be given the speed and the direction in which it's headed. So let's say you're given that an object is traveling at a speed of 5 under root 2 meters per second, and let's say that it's going northwest. Okay, now we have the speed, okay, and we sort of have the direction. Okay, and what we're going to do is we're going to merge the two, and once we merge the two, we're going to come up with the vector of its velocity. Okay, so I'll write velocity here instead of vector. So like I said, we're going to merge the two, and we're going to find out the vector of its velocity in terms of ai plus bj meters per second. Now, before I do that, let's find out that which of the two components is going to be, whether a is going to be negative or positive, or whether b is going to be negative or positive. And the way to do that is, if you remember your compass, so here's north, east, and here's west, and here's south. Now, northwest basically means that we are in the second quadrant, okay? We're between north and west. Now, that's what northwest means, right? Halfway between north and west. So that means that this angle that you're looking at will be 45 degrees, and this angle that you're looking at will also be 45 degrees. And we do this whenever it's northwest, or whether it's northeast, or whether it's southeast, southwest. That basically means it's halfway between the two directions that we're given. Okay, now, if it is halfway, let me just write this over here. And if we are given 5 under root 2, so remember 5 under root 2 that you're looking at is basically what this length is. Okay, so I'll write 5 under root 2 over here. Now what you want to do instantly is you want to make a 90-degree triangle over here. So that's exactly what I'm going to do. So we know exactly which of the two lengths is the A component and which of the two is the and which the other one is definitely going to be the B component. Okay, so now since this is heading rightwards and upwards, so one thing is for sure is that after I worked out my velocity component, A is going to be negative, so I'll put a negative here right away, and B is going to be positive. So I'll leave that as it is. And the reason why I'm doing that is just so that I don't end up forgetting it. And again, the reason why it's negative is because it's in the second quadrant where x is negative and y is positive. Or you can just look at it, okay, if it's heading northwest, that means it's going leftwards and upwards. Okay, so let's work out the adjacent and the hypotenuse. So if I want, let me try and color code it for you guys. So let's go with green. Yeah, so if I want the A component, so this right here is the A component. And if I want the B component, so B is the vertical component, so this is what the B component is. So let's talk about the A component. A is the adjacent side, and we have the hypotenuse side, so we can use cos. So cos 45 is equals to adjacent upon hypotenuse. So let's work it out. A is going to be equal to, now I've taken values just so that it's easy for us to work it out, but we're going to do another example where I'll take slightly difficult values so you guys know how to work out with the difficult ones. So cos 45 is root 2 upon 2. If I multiply root 2 upon 2 with 5 under root 2, so you're looking at cos 45 into 5 under root 2. So you're looking at 5. A is equals to 5. So that's what A is equals to. And if you want to work out what B is equals to, so you'll do, this time you want the opposite length and you have the hypotenuse, so you'll be using sine 45 equals to opposite, which is B, upon hypotenuse, which is 5 under root 2, and B here will also be equal to 5. Now I'm going to take these two and I'm going to put them back into the velocity vector, and now I know that the velocity of this particle is basically equal to minus 5I plus 5J inside the bracket meters per second. That means every second this particular object of mine moves 5 units towards the left and 5 units up, which is why it has a combined velocity of 5 under root 2 meters per second. So that's one example, and I'm going to do another example, and this time we're going to resolve velocity with the help of bearing. And yes, bearing is also something that can come, that you guys may be tested on. So let's say you have an object that's headed on a bearing of, let's say 200. In fact, let's not take 200. Let's say 300 degrees at a speed of, let's say, 3 meters per second. Now, if you think you're confident and you can work this out, so I'd suggest you pause this video and work it out. If you're not, then I'd suggest you just keep on watching. Now, in fact, just to make things slightly interesting, I'm going to change the 300 and I'm going to change this to 150 degrees. Okay, so my bad. So, and the reason why I've done that is because had I taken 300, we would have ended up in the second quadrant again. So I just wanted to change it slightly. Okay, so here's north, here's east, here's west, here's south. So bearing of 150. Now remember, bearing is something that is measured from the north. It's measured in a clockwise direction, so all of that is still relevant. Okay, so this is going to be 90, this is going to be 180, so 150 is going to be somewhere in between 90 and 180. Now if all of this is 150, now remember, we're only interested in just the angle that it's making with the horizontal axis. So this is going to be 150 minus 90, that means it's going to be equal to 60. Now as far as the velocity vector goes, this is what it's going to look like. Velocity is going to look like A times I plus b times of j meters per second. Okay, now, and this length that you're looking at is 3 meters per second. The hypotenuse is basically 3. So whenever you're given the speed, it's basically the hypotenuse. And that's something you should be able to figure out instantly. Now let's break this down into I and j. So here's the I component and here's the j component. Again, I'm going to try and color code it for you guys. So let me turn A into green. So this is what A is, and this right here is what B is. Now one thing you guys should do right away, just how we did it in the previous part, is that you should know that since it's in the fourth quadrant, so A will be positive because it's still heading rightwards, and B, however, is something that's going to be negative. So there you go. Now let's work out A and B. Okay, so as far as A goes, we have the hypotenuse and A is the adjacent. So we're looking at cos 60 equals to adjacent upon hypotenuse. So let's work this out. Remember that your calculator should be in degree mode for this. So we're looking at A is equals to 3 upon 2 or 1.5. So there you go. That's what A is equals to. Now let's work out B. So for B, we're going to use sine. So sine 60 is equals to opposite upon hypotenuse. So that means B is equals to sine 60 multiplied by 3. So we're looking at 3 under root 3 upon 2. Now if the question wants the exact value, then we're going to leave it as it is. If it doesn't, then you can write it in decimal. However, since this is not a final answer, I mean in this case it is, but normally in a question like this there would be a follow-up question, so I would prefer to keep it as in the exact form only. So now we can put A and B together and have our velocity. So we're looking at velocity equals to 1.5 A minus 3 under root 3 upon 2. Sorry, 1.5i, not 1.5a. 1.5i minus 3 under root 3 upon 2j meters per second. So this was the second case. Now I'm going to do the third case, which is not very common. It's kind of rare, but it's still part of our syllabus. So let's work it out. So we're looking at example number 3 now, I guess. Is it? Yeah, we're looking at example number 3. Okay. Now, in case 3, you can have, let's say that the question tells you that an object has a speed. If I'm not wrong, this is actually a past paper question that I have solved. Speed of 39 meters per second in the direction. I'm going to try and change it slightly. 5i plus, or in fact, let's say it's minus 5i plus 12j. I really hope it's not the exact same question, but anyway. So you may be given this, and the question may ask you to use this and find the velocity vector. Now, the way to do this is that the velocity will be equal to speed multiplied by the unit vector of the direction vector. Okay, so here's what I mean. So the speed is 39, and if I multiply this by the unit vector of the direction vector, so that means here's what I'm looking at, for minus 5i plus 12j divided by square root of minus 5 squared plus 12 squared. So here's what we're looking at. So 39 times minus 5i plus 12j. So minus 5 squared is 25. 12 squared is 144, 25 plus 144 is 69, and if you take the square root of it, that's equal to 13. So 39 upon 13 is equals to 3. So we're looking at 3 times minus 5i plus 12j. So that means we're looking at minus 15i plus 12 times 3 is 24, 36. So 36j meters per second. Okay, so these are the 3 different cases where you will be asked to resolve velocity, and I hope you guys have understood this. And in the next example, what we're going to do is we're going to take a full length example, and we're going to try and see how we're going to try and look at what the follow-up questions look like. Okay, so now we're going to look at how the follow-up questions related to constant velocity may look like. Now, again, a couple of things that a couple of concepts that I would like to clear before we head into some full length questions. So basically, let's say you have a particle which is starting at O. Let's say it starts at O, or starts from a point O. In fact, let me just write this as starts from O. Okay, O is the position from where it's starting. at a velocity of, let's say, AB. So we're dealing with the general terms, okay? At a velocity of AB meters per second. So if you want to work out where this object will be at t seconds, so here's how you do it. At t seconds, so since it's starting at O, that means it hasn't moved. That means that's what the starting point was. So it's not like it was at a point other than O. So if you want to find out where this will be at t seconds, all you got to do is you got to take the vector of the velocity and simply multiply it by t, and you will have where the object will be, where its position vector will be at t seconds. Okay, so I'll elaborate it here and write it over here that this, what you're actually finding out is the position vector at t seconds, and you'll find this written as r. Okay, so I'll also label it r. Now that means it may not always be the case that the object is starting from O. Sometimes it's possible that the object will start from a point other than O. Let's say it starts from A. Okay, we don't know what A is, and at a velocity of AB meters per second. Okay, now let me show you what this basically means. If an object is starting from a point other than A, that means, so if you have an xy plane over here, here's O, and this is the point A. Now from this point onwards, the object may be headed anywhere. Okay, we don't know where it's headed. It can be headed anywhere. It can be, and it can also be in whatever direction. So if you want to find out where it is at t seconds or after t seconds, whatever, so here's what you will do. So the position vector at t seconds will basically be equal to OA, which is a vector, plus AB, which is its speed, AB, and we'll multiply it by the number of seconds. Now bear in mind that this will not always be seconds. Sometimes it may be minutes. Sometimes I haven't seen minutes very often, but it could be hours also. Okay, so remember that even though I'm writing t seconds here, but it could also be t hours. Okay, so this is something you need to know. Now with this in mind, let's do an example question and let's see what that looks like. So here's one question that I have for you guys. So it says here that at 1200 hours, a boat sails from point P, the position vector r kilometer of the boat relative to an origin, t hours after 1200 is given by r is equals to 10:6. So if you do, what this 10:6 basically means that this object is not starting from O, this is starting from a point which is already 10 units rightwards and 6 units upwards from O. And 512 is basically its velocity, and that's where it's headed. And basically it's the vector of the velocity. Okay, now it says write down the position vector of the point P. So if I want to write down the position vector of the point P, that means you can see here the question says that it's starting from a point P. So OP is technically all what we're looking for. So that is going to be 10:6, and that's it. That's your answer. This I should mention is not a past paper question, and I'm sure you're wondering that how come it's so easy. That's because it's not a past paper question. We're just building the initial concept. Then I have a past paper question lined up for you guys also. Then it says write down the velocity vectors. If you want to write down the velocity vector, what you're looking at, 512 is what the velocity vector is, and since it's kilometers per hour, just like I mentioned, that it may not always be meters per second. So 512 kilometers per hour is what the velocity of the vector is. Now, if you have the velocity of the vector of the velocity, I think I have been saying vector velocity of the vector, vector of the velocity, and you want to work out the speed. So the way to do that would simply be square root of 5 squared plus 12 squared. So what we're looking at is that speed is equals to 25 plus 144, which is 169, the square root of which is going to be equal to 13 meters per second. Now see how speed is not concerned with where the object is headed. It just wants a value. It just wants how many kilometers per hour. I mean, at what rate does the distance change? And this is kilometers per hour because the distance is in kilometers and time is in hours. And then we head over towards part D, where it's asking us to find the distance of the boat. Now notice here it's asking us the distance. Now I'll tell you how you're going to work out the distance of the boat from P after 4 hours. So here's technically what we have to find out. Now once you understand what graphically what this means, then hopefully you're not going to have a problem over and over again. So since this object is not starting from O, it's starting from 10 and 6. So let's say here's 10 and here's 6. Okay, and this object is headed at a speed of 5 and 12. So that means 5 right and 12 up. So this is where the object is headed. And this is the point P. Okay. Now, this is the point O, and what the question basically wants, in fact, let me just straighten this up a little. Yeah. What the object basically wants is the distance of the boat from P after 4 hours. So since this object is starting from P, and we know that the vector P or OP is 10, 6. Now, before I can find out how far this boat will be at t equals to 4 hours, I need to know that where this boat will be, or rather how much this boat has traveled at t is equals to 4. So from this point onwards, I know that the boat is traveling at a speed of 5 and 12 kilometers per hour. That means every hour this boat moves 5 units rightwards and 6 units or 12 units upwards. And since it's positive, so that's why that is, since both the values are positive, hence rightwards and upwards. So all I got to do is, if I want that how much the boat has traveled at t is equals to 4, so here's what I'm going to do. I'm going to take the 5 and 12, I'm going to multiply it by 4. So if I do that, I'm looking at 20, and 12 times 4 is 24, 48. So we're looking at 48. Okay, so this basically means that at t is equals to 4, after 4 hours has passed, this vector that you're looking at is basically 20 and 48. Okay, now let's see what the question wants. The question wants the distance of the boat from P. Now this 2048 is basically the vector that I've highlighted. Now if you want the distance, now here's what you need to do. As far as the distance is concerned, if you have a vector and you want to work out the distance, all you got to do is you got to take the magnitude. So here's what I'm going to do. 20 squared plus 48 squared inside the square root. So let's work this out. Square root of 20 squared plus 48 squared inside the square root. So we're looking at 52 kilometers. Now, since the question asked us the distance from P, I did not take into account 10 and 6. Had the question asked us to calculate the distance from O, in fact, you know what? Let's add another part to it where we work out the distance from O. Now, if the question had asked you to work out the distance from O, let me write it over here. Distance from O at t is equals to 4 hours. So here's what I would have done. Let me just insert another page here. So in that case, what I would have done is, so let me copy this, paste it here. Yeah, now. So if I write down the position vector of this boat, okay, so I'll just call it R. So remember, it's OP, and P was 10 and 6. So 10, 6 plus 5 and 12 times t. So if the question wanted us to calculate the distance from O, so here's what I would have done. I would have taken 10, 6, multiplied 5, 12 by 4. So that's how we got 20 and 48. And then sum it up. So if I sum this up, I'm looking at 30. And let's see what 48 plus 6 is equals to. So that's 54. And then this is what the position vector of the boat is after 4 hours. So you know what I've just worked out? Here's what I've worked out. This is what I worked out at t is equals to 4. Now what the question wants over here is this distance, the one that I'm highlighting in green. So if you want to work out this distance, you know that this is the point from O to where the position is, to where the boat is at right now. So all you got to do is you got to take the magnitude of this, so 30 squared plus 54 squared. So let's see, what do we get? So 30 squared plus 54 squared inside the square root. So we're looking at 61.77. So we'll just lock it at 61.8 kilometers. Although this is not an actual question, this is something that I just sort of added so you guys have an idea at what the difference is between distance from O and distance from the point where it's starting. Anyway, so I hope this concept is clear now. Now let's move on and do an actual past paper question and see what that looks like. So here we have a past paper question, and this I should mention is from May June 2019, paper 1, variant 1. And let's get straight to it. So it says a particle P is moving with a velocity of 20 meters per second in the same direction as 3, 4. To find the velocity of vector P. So we just did a case where we learned how to find the velocity when you're given the speed, the velocity and the direction, or the speed and the direction. So it's so what we're going to do is we're going to take 20 and we're going to multiply it by the unit vector of the direction vector. So let's write it as 3i plus 4j for the time being, and then the square root of 3 squared plus 4 squared is going to be square root of 25, which is equal to 5. So we're looking at 20 into 3i plus 4j upon 5. By the way, How you give your final answer is totally up to you. Okay, there are different ways through which you can represent a vector. So I am going to simplify this. So 5 ones are 5, 5 fours are 20. So we're looking at 12i plus 16j. So this is equal to 12 and 16. Okay, there we go. All right, then it says at time t equals to 0, p has position vector 1, 2 relative to a fixed point O. Write down the position vector of p after t seconds. So we're talking about particle p and we need to write down its position vector of p after t seconds. So remember, it's not starting from O, it's starting from a point that is other than O, which is 1, 2. So if you want to write down the position vector of p after t seconds, so here's how we're going to do it. So we're going to take the point from where it's starting, so that's 1, 2, plus the speed, the vector of the velocity, which is 12 and 16, and we're going to multiply it by t because that's how far it will move in t seconds. There you go. Now here's question. Here's part 3, which says a particle q has position vector 17, 18 relative to O at time t and has velocity vector 8 and 12. Given that p and q collide, find the value of t when they collide and the position vector of the point of collision. So I've done a question similar to this in the last video, if I remember correctly. I have. So anyway, let's do this also. So as far as q is concerned, q's position vector at time t seconds can be worked out by taking the point from where it's starting, which is 17, 18, and in it adding 8, 12, multiplying that by t. Now since p and q collide according to the question, now whenever two particles collide, all we have to do is, because see, the reason why they're colliding is because they're at a certain point, both of them are at a common point at a certain value of time. So if you want to find out what that common point is, all you got to do is you just got to equate the two. Okay, so we're looking at 17 plus 8t and then 18 plus 12t. So this is what OQ looks like, and this I'm going to set equal to 1 plus 12t and 2 plus 16t because this is what OP was like. So you can equate any one of the two equations, you will get the right answer. In fact, one way to check is to solve both the equations and see whether you're getting the same answer or not. So 17 plus 8t is equals to 1 plus 12t. So 17 minus 1 is 16, 12 minus 8 is 4, so we're looking at 4t is equals to 16. Just writing it nicely, so t is equals to 4 seconds. And again, you could have used the other equation also and you would have ended up with the same answer. Okay, now this is not what we just had to find. We also had to find the position vector of the point of collision. So if you want to find the point of collision, so you're going to take this t is equals to 4 and you're going to plug it in any one of the two. Now remember, since we have equated the two to find out the point of collision, it does not matter whether you plug it in OQ or OP, you will get the same answer. So I'm going to plug it in OQ, okay, no particular reason why. So 17, 18, let me double check, yeah, 17, 18 plus 8 and 12 and multiplying this by 4. So remember, when you're multiplying a vector by a certain value, that means you need to multiply both of them, the I and the j components. So 17, 18 as it is, 8 times 4 is 32 and 12 times 4 is 24, 48. Now let's sum it up. So we're looking at 17 plus 32, which is 49. And we're looking at 18 plus 48, which is equal to 66. Now, had the question asked the distance from O, then we would have found the magnitude of this vector. But since that's not what it's asking, we'll just leave it here. So anyway, this was due on me for a very long time, and I hope you guys have understood this, and I hope you guys are well prepared for tomorrow's exam. And I just want to wish you guys the best of luck. I will be posting a video right after I'm done making this video as last minute tip. So make sure to go through that, and it'll be fine, inshallah. So take care. See you in the next video. Bye bye.